nth term of a geometric sequence is determined by the formula t sub n is equal to t sub 1 times r raised to n minus 1, where t sub n is the nth term, t sub 1 is the first term, r is the common ratio, and n is the position of the unknown term. If the first term of the geometric sequence is not given, the nth term is determined by the formula t sub n is equal to t sub m times r raised to n minus m, where t sub n is the nth term, t sub m is the given term, r is the common ratio, n is the position of the unknown term, and m is the position of the given term.
Now let us determine the nth term of this geometric sequence. We have 2, 8, 32, 128, and so on. And we are going to determine t sub 9, or the 9th term of the geometric sequence. So using the formula t sub n is equal to t sub 1 times r raised to n minus 1, we can determine the 9th term. Let us first identify the needed values to solve for the nth term. So our t sub 1 is 2. Our common ratio is 8 divided by 2 is 4. And then n is equal to 9. It is equal to 9 because the location of the unknown term is 9. Now let us substitute the given value. So we have t sub 9 is equal to 2 times 4 raised to 9 minus 1. Let us simplify by following the order of operations. So we are going to start first with the exponent, 9 minus 1. So t sub 9 is equal to copy 2, then copy also 4. Then 9 minus 1 is 8. Then we have t sub 9 is equal to, now between multiplication and exponent, we are going to get the power first. So 4 when raised to 8. So 2 times 4 raised to 8 is equal to 65,536. Then we are going to multiply 2 and 65,536. We now have 131,072. So the 9th term of this geometric sequence is 131,072. Now let us proceed to the next example. So we are given t sub 1, which is 3. R is equal to negative 2, and then we are going to look for t sub 7. Now, since the unknown term is t sub 7, that means the value of n is equal to 7. Using the formula again for the nth term, we have t sub n is equal to r, t sub 1 times r raised to n minus 1. Substitute the given value. So we have t sub 7, because we are looking for t sub 7, is equal to 3 times negative 2 raised to 7 minus 1. So again, we are going to perform the operations in the exponent. So t sub 7 is equal to 3 times negative 2. 7 minus 1 is 6. Then we are going to get the power of negative 2 when raised to 6. Copy 3. So negative 2 raised to 6 is 64. Now remember, when you raise a negative integer to an even exponent, the power is positive. But when the exponent is an odd number and your base is negative, the power is negative. Now let us go to the last step. We are going to multiply 3 and 64. So 3 times 64 is 192. So the 7th term of this geometric sequence is 192. So in our third example, we are given the general term of the geometric sequence, which is t sub n equals 2 times 3 raised to n minus 1. And we are going to determine the fourth term. So that means our n is equal to 4. Now using the general term, we are going to substitute the value of n. We have t sub 4 is equal to 2 times 3 raised to 4 minus 1. So t sub 4, again follow the order of operations. Perform first the operations in the exponent. So 4 minus 1 is 3. Then t sub 4 is equal to 2 times 3 raised to 3 is 27. Then multiply 2 times 27 is 54. That means the fourth term or t sub 4 of this sequence is 54. So in our fourth example, we are given the third term, which is 6, and the common ratio, which is 4. And then we are going to look for t sub 5. Now take note, we are not given the first term. Now, when you are not given the first term, you can use the formula t sub n is equal to t sub m times r raised to n minus m, where t sub m here is the lower extreme or the given term of the geometric sequence, and m is the location of the lower extreme or the given term of the geometric sequence. This formula can also be used when you are also given the first term. Now let us substitute the value. So by the way, our t sub m here is 6. That means our m is equal to 3. And we are going to look for t sub 5. So our n is equal to 5. Now substitute the given value. So we have t sub 5 is equal to 6 times 4 raised to 5 minus 3. Again, follow the order of operation. So copy 6, copy 4, and then subtract 5 and 3. So 5 minus 3 is equal to 2. Now after that, we are going to, get the power of 4 when raised to 2. So you need to copy 6 first. So 4 raised to 2 is equal to 16. It is not equal to 8 because 4 raised to 2 means 4 times 4. So 6 times 16 now is 96. So our fifth term is 96.